Have you ever wondered how to solve equations where the variable is buried under a root or raised to a fraction? Today, we will bridge the gap between radicals and exponents to make complex algebra simple and intuitive. Fractional exponents aren't just for textbooks. They are essential for modeling planetary motion, calculating compound interest, and designing advanced technology. Understanding these laws unlocks a deeper level of mathematical problem solving. The most important rule to remember is that the denominator of a fractional exponent represents the index of the root, while the numerator represents the power. This identity allows us to switch between radical and exponential forms effortlessly. Think of a denominator as a splitting factor. An exponent of 1/2 splits a square's area into its side, while an exponent of 1/3 splits a cube's volume into its edge length. It is a measure of dimensional scaling. Before we solve equations, remember that fractional exponents follow the same rules as integers. When multiplying powers with the same base, we add the fractions. When raising a power to another power, we multiply them together. To solve for x, our goal is to make the exponent equal to 1. We achieve this by raising both sides of the equation to the reciprocal of the current exponent. In this case, 3/2 cancels out the 2/3. When evaluating the constant side, it is usually easier to take the root first to keep the numbers small. Taking the square root of 4 gives us 2, and then raising 2 to the 3rd power gives us our final answer of 8. Let's try a radical equation. First, rewrite the square root as an exponent of 1/2. To undo this, we square both sides. This clears the radical, leaving us with a simple linear equation to solve. After squaring, we find that x plus 5 equals 9. Subtracting 5 from both sides gives us x equals 4. Always plug your answer back into the original equation to ensure it satisfies the radical condition. In this example, we must isolate the term with the exponent before applying the reciprocal. We divide both sides by 2 first, resulting in x to the 3/4 power equals 8. Now we are ready for the reciprocal. We raise both sides to the 4/3 power. To calculate 8 to the 4/3, we take the cube root of 8, which is 2, and then raise 2 to the 4th power. Our solution for x is 16. What if the exponent is negative? Remember that a negative exponent signifies the reciprocal. By flipping the fraction, we get x to the 1/2 power equals 5. From here, we square both sides to find that x equals 25. Be careful when dealing with even roots. Just like x squared equals 9 has 2 solutions, equations involving even roots may require you to consider both positive and negative roots, depending on the domain of the function. Sometimes, the math produces a fake answer called an extraneous solution. Since a principal square root cannot be negative, x equals 4 is not a valid solution here. Always verify your results by substituting them back into the original problem. To summarize, first, isolate the term with the exponent. Second, use the reciprocal power to cancel the fraction. Third, evaluate the constant side by taking the root then the power. Finally, check for extraneous solutions. Try this one: x to the 2/3 equals 9. If you raise both sides to the 3/2, you take the square root of 9, which is 3, and cube it. Did you get 27? Great job! You are now equipped to handle fractional exponents and radical equations with confidence. Keep practicing these conversions, and algebraic hurdles will become stepping stones. Thank you for learning with us. Generated by Vision Solve AI.